Okay, let us start with the basics of vector calculus. We will start with vector calculus. In the vector calculus, first let us start with vector differentiation. Vector differentiation. Here basic vector differentiation is called as a del operator, or it is called as nabla. So, the first thing we are going to study in vector differentiation is nabla, or it is called as a del operator. Del operator. So, it is denoted with a triangle like this, which is identically equal to dou by dou x into x cap plus dou by dou y into a y cap plus dou by dou z into a z cap. So, this is called as a del operator, or it is called as a nabla. Now, if you observe this one, this equation contains 3 terms. In each term, you can observe a differentiation here. So, exactly you can say that it is a partial differentiation. Everywhere we have partial differentiation. So, here in this partial differentiation, these are the differentiation with respect to which variables? Here you can say we have dou by dou x, dou by dou y, dou by dou z. So, these are the partial differentiations with respect to x, y, z. Okay. So, let us see, let us consider what is x, y, z. So, generally you say that what is meant by x, y, z means we are going to answer that it is a coordinate. Okay. So, these coordinates x, y, z, what is the purpose of these coordinates x, y, z? These coordinates are used to address a point in the free space. So, you can say the address or location of any point in the free space with the help of these coordinates x, y and z. That is why these coordinates are called as spatial coordinates. They are called as spatial coordinates because they are used to address a point in the free space. Okay. Now, can you tell me what are the units of this x, y, z? You know that x represents length along x axis, y represents length along y axis, z represents length along z axis. You know that all these x, y, z represents length along different axes and length is measured in meters. So, the spatial coordinates has units of meters because they are length. Okay. Now, if x, y, z are spatial coordinates, then can you tell me what is dou by dou x, dou by dou y and dou by dou z? We have 3 terms, dou by dou x, dou by dou y and dou by dou z. What are these terms now? So, here differentiations are with respect to x, y, z and x, y, z are called as spatial coordinates. That is why these differentiations are called spatial differentiation. They are differentiation with respect to spatial coordinates. So, they are called as a spatial differentiation. So, these terms are called as spatial differentiation. Spatial differentiations. Okay. Now, you know that already what are the units of x, y, z? They are length, they are measured in meters. Then what are the units of dou by dou x, dou by dou y, dou by dou z? These are the differentiation with respect to x, y, z or spatial coordinates or differentiation with respect to length. Length is in the denominator. So, x, y, z are in denominator. So, units are 1 by meter or meter inverse. Meter inverse are the units of dou by dou x, dou by dou y, dou by dou z. Now, from this can you tell me what are the units of this del operator? So, here each term has units of 1 by meter. So, the del operator is also measured in 1 by meter or meter inverse. So finally we say that. So del operator is a spatial differentiation and having a units of 1 by meter or meter inverse. It is the first point. Okay. So it is a spatial differentiation. We say that del is a spatial differentiation. Spatial differentiation. Fine. This is the first point. And then second point, we need to know that this del operator or this equation is a vector or scalar. Now, if you observe, each term of del operator has a dou by dou x multiplied with ax cap. Ax cap is x-axis direction. Dou by dou y into ay cap, y-axis direction, plus dou by dou z into az cap. Az cap is z-axis direction. So here each term contains direction, x-axis direction, y-axis direction and z-axis direction. Okay. Whenever any parameter contains direction, then this parameter is called as vector. So I would like to say this second point, this del operator or nabla is a vector quantity because it has direction. Okay. So this del operator is a vector quantity. Vector quantity. Okay. So finally we conclude here. So del operator is nothing but a spatial differentiation and also it is a vector differentiation because it has a direction. It has a differentiation and also direction. Okay. So these are the concluding points. The del operator is a spatial differentiation and also it is a vector quantity. Okay.